How many molecules of ethyl ether, C4H10O, are there in 47 cubic centimeters of the pure liquid if its density is 0.71 grams per cubic centimeter? In this case, we will solve the problem using two techniques, the chemical conversion factor and algebraic theorems. We will start with the chemical conversion factor. The first step is to write the given data in the format of the chemical conversion factor, where each term consists of a value, a unit of measure, and a substance identity. In this case, we have 47 cubic centimeters of ethyl ether. Then, we multiply by the first conversion factor, which consists of placing cubic centimeters of ethyl ether in the denominator and grams of ethyl ether in the numerator. In this case, we assign the theoretical unit to the cubic centimeters, while the grams are assigned the given density value from the statement. Once in grams, we proceed as we have done in other mass cases. In the second conversion factor, we place grams of ethyl ether in the denominator and moles of ethyl ether in the numerator. Here, we assign the theoretical unit to the mole and determine how many grams are in a mole. The answer to this question is the molar mass. To calculate the molar mass of ethyl ether, we sum 4 times 12.01 for carbon, 10 times 1.01 for hydrogen, and 16.00 for oxygen. The result, expressed to 2 decimal places, 74.14, is expressed in units of grams per mole. In the next conversion factor, we place moles in the denominator and molecules of ethyl ether in the numerator. Again, the mole carries the theoretical unit, and the number of molecules in a mole of any substance is always Avogadro's number, which is 6.022 times 10 to the power of 23. In the dimensional analysis, we eliminate units and ones that multiply and divide. If any unit has significant figures, they must be taken into account. We extract the significant values to enter them into the calculator and perform the arithmetic. Now we solve the arithmetic, 47 multiplied by 0.71, then multiplied by 6.022 times 10 to the 23, divided by 74.14. The raw result must be rounded. Remember, the data given by the statement is assumed to be measurements, and both the density and the volume have 2 significant figures, so we round to 2 significant figures. Given that the first non-significant figure is less than 5, we round down, and the solution is 2.7 times 10 to the power of 23. To apply the alternative technique, the algebraic theorem, we select the corresponding formula from our formula sheet, which indicates that the number of molecules, represented by italic N subscript J, is equivalent to the product of Avogadro's constant times the density, times the volume of the substance, divided by the molar mass. We simply follow the equation. In the formula, we substitute J with the identity of the substance, which in this case is the molecular formula of the substance. Then, we substitute Avogadro's number with 6.022 times 10 to the power of 23 in units of 1 per mole. Then we substitute the density with its given value in the statement, 0.71 grams per cubic centimeter. We substitute the volume with 47 cubic centimeters. and we substitute the molar mass with its calculated value of 74.14 grams per mole. Note that in this method the identity of the key substance is contained in the dependent variable and does not need to be placed in the operational terms. When performing the dimensional analysis, the units cancel out, which makes sense because in algebraic form the number of entities is a dimensionless parameter. This differentiates it from the form of conversion factors. By eliminating the ones, we find that the significant terms are the same as those generated by the conversion factor, so the value is the same, 2.7 times 10 to the power of 23. In this case, it is implied by the italic uppercase N of the theorem that we are talking about entities of ethyl ether. Since ethyl ether is described as a molecule, we are implicitly talking about molecules, without needing to express it with units and identities as is done with conversion factors. Well, that was all for now. If you liked the presentation, don't forget to subscribe, like, and share it. That keeps this channel alive. See you next time.